like, it is tucked in. It's just not done well.
Why is it whenever my mask breaks, I just know how to fix things? I'm such a mechanic.
I did the exact same thing in my
Can I go to my locker?
No.
No? I'm a mechanic. Okay. I'm a mechanic.
All right, Rowan, stop touching my thing and close the door for me.
Randy, that's what I was asking for the homework. Because I forgot to write it down. You ain't never told me.
Okay, quiet, please. All right, I asked for quiet, and all I got was talk. All right, quiet, please. Get out your homework.
Someone's trying to frame me. There's a bunch of already torn up paper in this desk. Yeah, I'm good. Marlon, how do you make you feel that everyone moves away from you?
Okay, quiet, please.
I'm being quiet.
All right, so the homework we had, it seemed like a while ago, was, and most of you did it in class, it was I gave you two binomials, and you were supposed to work through the process of starting doing this in your head. This will turn in more like multiplication tables, in the sense that you're going to look at a binomial times a binomial, you're going to write the answer. I do want you to use some common sense. I mean, is this going to be a case for every person, like they can do this? The answer is probably no. Yeah. So in the big picture is this: as long as you can multiply a binomial times a binomial, which we already had a quiz on last chapter, you guys were fine on that. We're okay. The reason why they had a whole section where they were trying to get you to do it in your head is because it's a very useful skill of where we're going, right? Today, you're going to see one example of that. I'm going to show you that you can multiply a binomial times a binomial to get to an answer. And then why in the world we want to try to memorize it? And that's because it's going to get us this thing called factoring very quickly and easily. And factoring does require you to understand this process of multiplication mentally in your head. All right, any questions? All right, of course it covers up the screen. All right, today's 27th. All right, so keep the talking down so I can call up the answers and we can grade this. Here we go. 1 through 21. I'm going to just call out the evens since the odds are in the back of the book. Okay. Harley, you should have your homework from the last day that you were here. Find that. That's what I need from you. All right. Number 2, x squared plus 13x plus 42. Number 4, c squared minus 15c plus 54. Number 6, y squared plus 4y minus 12. Number 8, u squared minus u minus 90. You put minus 1u, same thing. Number 10, 4 minus 5x plus x squared. Number 12, 2r squared plus 11r plus 12. Number 14, 4k squared plus 15k minus 4. Number 16, 10n squared plus 9n plus 2. Number 18, 6 minus 13r plus 6r squared. And the last one, number 20, 6x squared minus 5x minus 6. All right. But how many you missed on the top, please? All right, another quick speech. Hey, today is your first, we did a day of factoring. I gave you a polynomial, we factored out one thing. Today is your first quadratic trinomial factoring. It's actually a quadratic binomial, but minor point. So today is your first like big boy, big girl day of factoring.
You keep saying today's our first day.
It is, right? Since I don't know if you heard the conversation Riley and I had, we were supposed to have the quiz tomorrow, right? Well, since the snow day, we pushed things back one. Then we put the quiz on the very next day that we got back from a 5-day weekend. I think that's probably a bad idea. So I will do a full review day. We're going to review lots of things, but one of the things we'll review is what will be on the quiz. So we'll worry about what will be on the quiz next Tuesday. Last note, parent-teacher conferences. 2 quick notes. One, if you have a D or F in any of your classes, you are scheduled to have a parent-teacher conference.
Every
Okay?
teacher or just the teacher?
Any teacher. The way that we do parent-teacher conferences in upper school, I mean, we teach 140 to 160 kids, depending upon the year. So 2 days would not be enough time to meet with all the parents. So we say, well, which kids do we really need to meet with? We need to meet with the kids that aren't passing. Why? 2 reasons. 1, obviously to help them, but 2, at this school, we're not one of those, well, it doesn't matter, you're going to pass. You just show up and you kind of pass. You're in high school now, so we don't say you repeat freshman year, right? We just don't give you credit for it. So in essence, you got to repeat freshman year for those classes you failed. That's like most high schools do this, by the way. So most middle schools do not, like you just got to show up, you're going to high school. As soon as you get to high school is when all of a sudden they start cracking down on the, oh, you failed the class, you don't get credit, you don't graduate. So you got to go to summer school, you got to do something called credit recovery, that sort of thing. Our high school is the same thing. If you don't pass, you don't pass, right? Meaning like you will not graduate from high school if you fail any class. You have to repeat it. Okay, you repeat it at summer school. There's some other mechanisms to help you out, but mostly it's summer. So that's why I always say, hey, you don't pay attention, you're signing up for summer school. That's for any high school, by the way. It's called credit recovery. So parent-teacher conferences, we just want to make sure that we meet with the kids that are at least on track to fail, right? Because we can fix things now. We can't fix things at the end of 3rd quarter. We can fix things now. Hey, this is what we got to change. This is how we can help you more. Why are you failing? What can we do better? What can you do better? That sort of thing. It'll be a conversation with all of your teachers. You have 7 teachers, 8 counting your student advisement teacher. Well, they'll be there anyway. So you're going to meet in a room with all of your teachers, right? So therefore, if you're passing my class, and all of a sudden I find out that you're failing science, usually that's the case, or you're failing, language arts or history. Those 2 courses kind of go together, type thing. So what typically happens is no kid fails math and science. No kid fails history and language arts, right? Or the kid fails everything. We do see that. But usually what happens is the kid that's doing poorly in one, that they have their teachers there like me, if you're passing math, but I do have a kid here who has an A in one of their in my class, and they're failing one of their other classes, and it ain't science, it's history or English. I can at least say to that kid, like, hey, they're doing great, right? Like they're a good kid, they're passing math, the issue is not math, they're doing a good job, right? Let's see what we can do to help you with those other classes, type thing. So you don't get to hear nothing but negative, 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 unless you truly are failing all your classes, right? For the kids that have C's and higher, we're choosing not to meet with you. That doesn't mean we can't have a conference. It just means we're not going to have a conference on next Thursday or this Thursday, Friday. Your parents have to set up a separate conference, and we'll have it with the individual teachers. But parent-teacher conference 1st quarter or between 1st and 2nd quarter. It's a really good thing to have so that we can at least have another way before it's the end of the year, like, look, you failed Algebra 1, right? Okay, here's your homework, copy it down. And usually when we ever have parent-teacher conferences, it usually goes the same way. They have all these missing assignments, and they have a failing grade. And it's usually those 2 things go hand in hand for my class, and a lot of the other classes as well too.
So
I'm technically passing.
That's a relative term.
I get to meet your parents
You're
9:20.
the only, this class is the only reason I'm playing with conferences. The only reason. Everything else I'm fine with.
Sure.
In fact, your mom emailed me this morning.
Oh, did you?
Yeah, Mom told us in the car this morning, if we fail any class, we're gonna get punished. I was like,
All right, we're gonna have a conversation, and remember, it's to help you. It's not like, oh, here comes your punishment. Line up for your spankings, you know.
she said that she's slowly gonna start teaching our freedom.
Well, that's what parents do. Yeah.
If we start failing like every class, Piper.
Yeah. Yeah, so for a good point. So for lower school, they always say, that's K through 6, they always say they just want to meet with the parents. For upper school, we want to meet with the kids and the parents at the same point. That way there's no loss in communication. Like the message that I'm sending to you and the message your parent is sending to you, we want to make sure that those are the same so that we can all sit in one room together. I mean, all your teachers are going to be there, by the way. So it's not, so
All at once?
yeah, even if you're only failing one class, so all your teachers, that way you get to hear from the good teachers and the not so good teachers. Yeah. That way your parents don't have to come here for 2 hours. They can knock this out in 15 minutes. Okay, here we go. So what a nice, simple, it says the product of a sum and a difference. So the title is a little misleading. You're really basically going to be factoring something today, even though it doesn't say that. All right, so it's really your first day of factoring a quadratic. The other day that we factored it was just division. This is going to be straight up this thing called factoring. All right, so last class we tried to do this mentally. And hopefully some of you learned that this is, well, this gives you, this gives you,
5x.
and this gives you, so minus 3x and a positive 5x would give you, and then the last terms would give you, so we get x squared, you said plus 2x minus 15. If you're not there, if you still require to do this by hand, scratch, that's fine. I just will say that the factoring process really would like you to be able to do this in your head. It just makes the factor a little bit easier. Okay? All right. This one in yellow is a quadratic. Quadratic because it's to the second power. Remember, if it's to the first power, it's linear, right? Quadratic, cubic. We won't see cubics this year, but this is a quadratic, and there's 3 things here. 1, 2, 3 things separated by addition and subtraction. That's what makes it a trinomial. Today we'll be factoring a quadratic trinomial. All right. The next 2 classes, this book does it a little bit strange. There's a lot of things the book does strange. This is another one, but I actually agree with this. They factor the special case ones before they factor the regular ones. Right? This is a really complicated thing. It is, if not the most complicated thing we'll do this year, factoring quadratics. There ends up being the special case ones, and those come in 3 flavors. And then the normal ones, and they come in 2 flavors. So there's 5 things that you got to remember, which is a lot. Most math books do the normal plain Jane ones first. This book doesn't. It does the special case ones first. In some sense, the special case ones are the easiest ones to factor. Like today, you'll all be factoring really quickly. It's easy, okay? But I will say that this idea of factoring a quadratic trinomial gets crazy complicated towards the end here, okay? If you're absent any day for the next 2 weeks, right, it is critical that you either watch the class online, get help from an adult in your family that knows how to do this stuff. Everyone teaches it the same way. Or 3, I see you for some tutoring. We do this. If you miss a class, it's going to go badly for you really quickly. Now, everybody gets sick. I know that happens. There's trips involved, whatever. But I'm just saying we can't just blow this stuff off. All right. The next 2 classes tomorrow, we're going to look at the special case ones. They are the easiest ones to factor. Okay? The normal ones are actually the hardest. Okay, so these are going to come in 3 flavors. We'll do the easiest flavor today. You guys are going to love this one. It's really simple. Okay. The special case ones, I'll just say, most kids forget that there are special case ones entirely. When we get to the regular ones, the technique that we use for the regular one, which is complicated, you can also use for special case ones. So we can think of this as, I don't know, memorization, like your multiplication tables, you memorize those. What I'm going to show you, and this is really, I shouldn't put this because there'll be some kids right now that as soon as they see this bullet, not required, like, whoop, not paying attention, right? I will say this, the kids that do pay attention, they'll look at, oh, it's one of those special case ones and get the answer in 5 seconds. You'll be spending 2 minutes trying to factor it because you won't remember that it's a special case one. We will see the special case ones come up frequently. Like I'll point it out every time, hey, look, special case one. You're like, oh, yeah, why am I solving it the normal way? It's a special case one. If you can remember this, this will absolutely help you out. Really speeds up the calculations. All right, so I said 1 flavor today, 2 flavors tomorrow, and then next week is when the real factory begins. I haven't taught a regular Algebra 1 class in 4 years. So today you're not gonna have any problems, but next week, I really need you to, like multiple people, not the smart kids, but the more average kids, that if you're struggling with this, let me know. Like I didn't get it, the homework was killing me last night. I didn't get most of this stuff. And I was checking the answers in the back of the book and I'm not getting it. We can slow down and we can take a review day, no issues whatsoever. I think that I teach it pretty well, like how to factor, but I also don't want to lose a third of the class and find out come quiz or test day that, wow, look how many people failed. Okay. Oh, wow, this looks complicated, right? It's not as complicated as what this looks like. So we're going to do a binomial times a binomial, the thing that we did mentally last night for homework, except instead of having numbers, I have nothing but variables. Okay?
Haven't we done that before?
Well, what you haven't realized is that this is a special case one. So what we're going to do is we're going to come up in this box right here. We're going to come up with the rule for multiplying any one of these special case ones. So let's see. Let's identify why is it a special case. Well, when both things are exactly the same, this first term in both binomials, this one's an A and this one's an A. That would be the case where it was an X times an X or a 2X times a 2X, right? Secondly, the second term in each binomial is opposite each other. One's positive and one is negative. You've seen this before. In fact, I even pointed it out to a couple. Hey, look, that one's one of those special case ones. I'll tell you what it means here in a second. To come up with the rule, you guys are going to come up with the rule. So let's see, I got first row, second row, third row, fourth row. I usually do this in tables and non-code because I have tables squeezed together. So this is first row, second row, third row, fourth row. Do you see that? I'll do the fifth one for you. Okay? First row, multiply. Second row, multiply. Third row, multiply. Fourth row, multiply. Go. 15 seconds. Go.
We're the third row, right?
You're the third row. First row, second row, third row, fourth row. Multiply. This was the homework from last Friday. You're on third row. Just multiply those two binomials. First row, second row, third row, fourth row, Mr. C's. You should be, right? It's a mental thing if you caught on. If not, it's like 15, 20, 30 second stops. All right, first row, who am I calling on? All right, what's the answer? Go. Wow. Tristan, what's the answer?
I didn't even figure out.
No, I didn't.
Just say the answer.
I don't know. Okay,
Always call me first.
X squared, 3x, and then, yeah, I know that. Well, I know it, I just.
Anna, what'd you get? She got x squared minus 9. X squared minus 9. Interesting. Second row, who am I calling on? What do you got, Riley?
I have x squared minus 16.
She got x squared minus 16. Third row, what do you got, Josie?
I got 4x squared minus 9.
4x squared minus 9. Last row, who am I calling on? Rowan, go.
No, she actually does.
9x squared minus 16. And the last row is 16x squared minus 25. There's a pattern here. The pattern will be revealed in our answer that we put right here. If you notice that your binomials are a special case one. And the special case one is, once again, notice in each one of this, the first term of the first binomial is exactly like the first term of the second binomial. See what I'm pointing to? The first term of the first binomial is exactly like the first term of the second binomial. Does that always happen? No. But in this case, it did. Secondly, the second terms of each binomial are opposite each other, meaning one's positive and one's negative. I got a positive 3, I got a negative 3. I got a positive 4, and I got a negative 4. Negative can come first, positive comes second. That's not the part that's different. What's different is one's positive, one's negative. If you're at this case, now let's look at our answers and let's see if we can come up with a rule. I got a 4. Where did this 4 come from? It came from multiplying A times itself. What's 2 times 2?
4.
What's 4 times 4? That's where that number came from. Every single time it's x squared, as long as, of course, that A is x. Where did the second number come from in our answer? It came from taking the last term and doing what with it? Multiplying it by itself and adding a. Look, every single one, the answer is negative. If we had to write a rule, the rule, and this is what you're going to write down in box number 1, this is the rule. You take whatever this first thing is, and you square it. What's x squared? What's 2x squared? What's 4x squared? You see what I did? You take whatever this is, I don't care, either one works, and you square it. So I take A and I square it. Every single time the answer is what? Positive or negative for the last term. So it's going to be minus. And then you take the last thing. I don't care. Take B or negative B. Either one and square it. Oh, that's the rule. So how does this speed things up? Because you don't need to do what you did on Friday. You just take the first thing, square it, take the second thing, square it, put a minus in between. Notice, we've lost that middle term. Before, when we multiplied a binomial times a binomial, we got a trinomial. The only time we don't get a trinomial is when it looks like this special case. The first things are the same. The last things are the same, except one is positive and one is negative. If you're on the ball and you notice, hey, it's a special case one, you can write the answer lickety-split. If you're not on the ball, guess what? You're doing what you did Friday. Some of you can do it in your head. Some of you got to stack them. Some of you got to use the distributive property. But if you're on the ball and you come to one like, hey, look, special case, guess what? Everyone will be tonight for homework.
Yeah.
A special case one. Okay? It speeds things up immensely. Hey, here's the rule. You ready to see how today is easy? What's the answer? You see how quickly that's done? But that's only because this one is a special case. This only happens infrequently. But when you have the same thing and opposite signs in the middle, we lose the middle term. Tomorrow, we're going to get back to middle terms. And for the rest of the chapter, we'll have middle terms. But the one time you lose middle term, it looks like this. This is a really quick thing. You got to be careful. It only happens infrequently. Hey, look. Same thing, opposite signs. Keep talking. You said 9x squared.
Minus.
Yes.
206.
Oh my God, 81. I thought you had it.
Yeah, almost there.
Well, you knew what to do. Okay. Hey, you tell me, easy or really hard? This one's easy. The issue is that this only happens infrequently. Most of the time, you got different things. Doesn't matter, you got pluses or minuses. There's different things going on. But on this one case, special case, Mike, the answer is?
4 is squared.
Thank you, Mike.
Sorry.
Mike?
Not. 91,000.
Square the first one. Square the second one, put a minus sign in between. 3 squared is not minus 9b squared. Okay? See how easy that is?
Oh. So that's just all you do?
Rowan, what's the answer? It is backwards. You still process stays the same. Square the first thing. First one. Square it. Square it. Square the second one. 4x. You put a minus sign in between and you're done. Hey, are you paying attention? I'll just say, the kids that are paying attention, they're like, okay, got this. He can shut up right now.
Yeah.
There's a bunch of kids out there that haven't been paying attention. So for those of you that were paying attention, keep the chit-chat down. Yes? You'd have to write minus 4x squared plus 49. Okay? All right, let's do box 2 together. Here we go. Hey, if it's a special case, the first thing will be the same, and the second thing. I really got to stress this point. You're going to see nothing but special case ones today, and then on tomorrow and the rest of the week, next week, they won't be special case ones. But if they are special case, you square the first one, x squared. You square the second one, that's 81. You put a minus sign in between. Yes? Chris, can you do the second one all by yourself?
Yeah, it's 4x squared minus 16.
Like I said, the kids that are paying attention, this will come very quickly. If you're not paying attention, Algebra 1 is really hard. But if you are paying attention, then most of the time, by the time we get to the end of Algebra 1, they're like, well, Mr. C was full of you know what, because this was pretty easy. No, it wasn't pretty easy. You just paid attention. Algebra 1 is hard. But if you pay attention, you understand it. All right, I got 3. If you want to do them by yourself, you want to do them together.
I want to do it by myself.
All right, do box 3 all by yourself. Kaylee, yay, nay? Good. But Kaylee, I do want you to remember, you've got to identify it's a special case. Same, opposite signs. Same, opposite signs. Same, opposite. If you still have your book out, you look at what we did Friday for homework, section 5.4. There was only, I think, one special case. No, there's none special case I gave you for homework. All right. Lily, you got the first one? X squared what? Minus 1. Very good. Julie, second one. Perfect. Good job. Okay. Ari, you got the last one? Last one. I'm not sure what you were saying that first time. Okay. Do we have this or not?
Yes, okay.
Sarah, thumbs up, thumbs down? Which one?
She's trying to suppress my attention.
Sweet. Okay. I had another box of more complicated ones.
X squared plus 4, and then 25.
So notice these become slightly more challenging when they get more complex, but the process is still the same.
25 squared.
2 squared is 4. 3x squared is 9x squared. So the answer would be 4 minus 9x squared. Tristan, middle one?
X squared minus 25 x squared.
Perfect. Tristan's got this. The last one is the hardest one. Hannah, what do you got? Very good. Now, some of you may have forgotten that when you square, you multiply exponents. 2 times 2 is 4. Well, that's the same as adding. Okay, yeah, that's the one case that's true. Do we got this or not got this?
We got this.
All right. So that first part is pretty easy, but it is new. So now that was pretty easy, and I never had class ever say, well, that was hard. But now it becomes slightly more challenging. All right, look at the board. New idea. Look at the board.
I did it.
You just went from here to here, yes? Now we're going to go from here to here. This is the F word. This is factoring. Listen, please. Listen. Factoring is the process of writing a polynomial as the product of two other polynomials. Factoring is the process of writing this polynomial as the product, multiplication of other polynomials. That's what we're about to do. The one nice thing, and this is the only time in tomorrow, that it will be nice is this is a special case one. Generally, this idea of factoring is minutes long process. I mean minutes. When we get to the most complicated one that we'll do by Wednesday next week-ish, right? I don't know, by Thursday next week, it's gonna be 5-minute process. Like a 5-minute process to factor this sucker. This is a 10-second factoring. This only happens when it's a special case. The factoring process is only really easy when it's a special case one. Hey, we got a special case one. Okay, so here's how it works. Where did this 4 come from? And how did you change a 2 to a 4? You squared it. So what's the inverse of squaring? So what's the square root of 4? How do you go from a 3x to a 9x squared? You squared it. So the inverse of squaring is, what's the square root of 9x squared? 3x. Okay? Notice the pattern. It's the square root of the first thing, minus plus, or plus minus, either one's fine. Square root of the second thing. That's the pattern. So this is called factoring. When we go from yellow, we go from right to left. Right? So write this down, please, somewhere. And I should have made this a box. In blue here, with the box around it, is how you turn it from one to the other. If I give you the quadratic and ask you to factor it, this is the pattern. But here's the only kicker. This is in the book, but why I don't like it. It's not b squared and then b, it's the square root of each one. The square root of a squared is a. The square root of b squared is b. So what you're really doing is you're taking on, I throw this up every year, and the kids that aren't paying attention, they kind of get lost on this part. You're taking the square root of each one. I take the square root of a squared, that's a. I take the square root of b squared, b. I write 2 binomials, multiply together, I make 1 minus and 1 plus. It doesn't matter which one. You want to make your first one positive, your second one negative, that's fine. Okay? I see wrinkled foreheads. We probably need to do some examples, yes?
It's easy.
All right, let's do some examples. I'll leave this up here. Hey, check it out. It's one of those special case ones. What's the square root of z squared? What's the square root of 49? So this is going to turn into z minus 7, z plus 7. Okay? You do have to ask yourself one question. I'll check the book here in a second. If this was a 48, we would say it's not factorable. Tonight for homework, what page should I give you?
2 of 6.
I don't remember any. They are all factorable. Okay. Until we get down, yeah, you're not going to get those. So everyone I'm giving you is factorable. Okay. You do have to ask your question. Is this a perfect square? Is this a perfect square? 1 is a perfect square and 49 is a perfect square. Okay. So z minus 7, z plus 7. And like I said, you could say z plus 7, z minus 7. Whichever way you like to say it. Okay. Is 16 a perfect square? Is 9 a perfect square? So this is one of those special case ones, no middle term. Square root of 16 is? Square root of 9 is? So this turns into 4 minus 3x, 4 plus 3x. Do you see what I'm doing here? This blue thing will be important later on.
13 plus 15.
Hey, perfect square, 25, yes? Perfect square, 81, yes. Square root of 25 is We're going to attach an a to it. Square root of 81 is, but we attach an x to it. So this is 5a minus 9x, and then 5a plus 9x. Yes? Hey, you're doing challenging math here. This is challenging. We'll get there. Quarter. Square root of 4 is, square root of 35 is, there ain't no square root of 35 because 35 is not a perfect square. So this one, even though I'm looking at homework, they are all factorable. We would say this one is unfactorable. Okay? So not factorable, unfactorable. I like throwing it up there because it will happen. All right, box number 5. Here we go. Hey, square root of x squared is, square root of 100 is 10. So this is x minus 10 and x. Hey, I need you guys to be brave now. And who doesn't get this? Josie and company. Turn down the volume, please. No one's being brave. That leads me to believe that everyone's got this.
I do got this. And it's easy.
Okay.
It's actually really easy.
Square root of 4.
2x.
Square root of 81.
9.
So this is 2x minus 9. Boy, if all factoring was this easy, this would be an easy chapter. I'm just going to say, special case ones are really, and this is the easiest of the special case. Tomorrow we'll do a bit more challenging, but they're still pretty easy. And then next week when we really start to factor trinomials, it's a bear. It's a bear. Sierra, stop. Okay, what are we on, box 6? This one always tricks people up. The square root of 1 is 1. So this is 1 minus 6x, 1 plus 6x. Hey, I don't want to go too fast if I'm losing people. Are we good? Harley, you should be the most lost. Are you lost? Good. Which one? The top one? The square root of 1 is, so the first term's going to be a 1. And the square root of 36 is, that's why there's a 6x, right? This one's weird because it's just written backwards. Okay? Yeah, let's do the second one. Square root of 64 is, and the square root of 4 is, so this is going to be 8x minus, and then 8x plus 2y. Got it. Ugly ones, these start, there's only a few of these. 15, 16, 17, 18 are like this. Which ones did I give you tonight for homework? And then 20 what? Okay, so I didn't give you 15 beyond that, so that was pretty good. Okay, good. That was kind of it, right?
Yeah.
Who's done their homework, Josie? You tell me, easy?
I did it myself. I didn't listen
I
to
shouldn't
anything you
ask
said.
the people that already done their homework because they're already doing it first thing.
I didn't listen.
Chris, good? Michael, good?
Expecting
Sarah, we're still thumbs up or not thumbs up?
Fix it.
Julie, good? All right.
Destroying my code.
Hey, we got 10 minutes left. You could easily get this whole thing done right now, right? And that way I'd be here to answer questions. So how about we all get started on the homework? And Sierra, Rylan, Josie, we're not going to do what you're doing right now. So you guys can work on stuff from another class.
You haven't been doing anything.
Landon, I'm sorry, Rylan. Rylan, you were perfect today. Although I didn't ask you a single question about this. Okay, good. Let's see. Haley, any questions? Haley, are you on? Nope, she's not on. All right. I will end the video right here. If you have any questions, send me a chat or email.